Okay, another redox titration. This time we've got to determine the water crystallization of iron sulfate. So in other words, we've got to find out the value of X in that compound. Right, now if you want to read the question and then pause the video and then restart it to see if you've got the right answer, well, I'll do the working out. So pause your video now. Okay, and I'll tell you the right answer. The answer here, X is equal to 7. There's 7 water molecules per iron sulfate. But let's do the working out now. Okay, so I find it helpful to draw some little pictures here. So we're going to make up a solution in the 250 volumetric, yeah, and then take 25 out of that for titration. Okay, so let's draw some little pictures. We have got our volumetric flask there, 250, and what we put in there, we have 6.4 grams of 6.4 grams for 4 grams of iron sulfate hydrated. We're going to take 25 of that out, so a tenth, put it into a conical acidifier. Yeah, you've got to acidify it. Remember, we'll write the half equations in a bit, but you need H+ ions for manganate to act as an oxidizing agent. And then we're going to have our manganate in the burette, purple manganate here. Concentration of that is 0.02 moles per decimeter cubed. And the amount we needed is 23.2 centimeters cubed. Right. So, half equations. Well, we want the manganate one, which you should know off by heart, which is MnO4 minus plus 8H plus 5E minus, sorry, and that goes to Mn2 plus and 4H2O. And that is the reason, those protons there, that's the reason we need to acidify our iron 2 sulfate solution in the conical flask there. All right, and the iron is a much more straightforward, so we get our very pale green iron 2 sulfate, and we oxidize it. Actually, it goes to a sort of yellowy color, iron 3 plus, and we're going to need an electron there. So we can see the ratio, the molar ratio, it's 1 manganate to 5 Fe2 pluses, because you know, that one is a 5 electron process, this is 1 electron process, we have to times that equation by 5. Right, what can we work out there? Right, can we work out the moles of iron sulfate? Well, you know, we've got a mass, but we can't work out the moles of it because we don't know the MR, because we don't know the value of X. So what can we work out here? Well, we can work out the moles of manganate. Let's see where that takes us. Let's write that down. So first of all, you know the concentration and the volume. So moles manganate, conc times volume, concentration 0.02, and the volume is 0.0232. That's in dm cubed, the volume in dm cubed, and that gives us 4.64 times 10 to the minus 4 moles of manganate. Now we know it's a 5-to-1 ratio, so we can work out the moles of iron 2 plus there then. Let's do that. Moles Fe2 plus is equal to 4.64 times 10 to the minus 4 times 5. That is equal to 2.32 times 10 to the minus 3 moles, and that is in the volumetric, the 250, yeah, in 250 centimeters cubed. but we want to work out, we only take out 25. So we, sorry, this is the moles in, not in 250, that's the moles in 25. We need to work out the moles in 250. So the moles of Fe2 plus in 250, just multiply it by 10. So that's going to be 2.32 times 10 to the minus 2 moles. Now we know the moles of Fe2 plus, so that means like 1 mole of iron, of the hydrated iron sulfate, contains 1 mole of Fe2 plus ions. So the moles of the iron sulfate, so moles of the hydrated iron sulfate is equal to the same, 2.32 times 10 to the minus 2. Now we know the moles of this stuff, and we also know the mass, because the question tells us that it was, what was it, 6.44 grams. If we know the moles and the mass, moles is equal to mass over mR, we can work out the mR of the iron sulfate, and if we can do that, then we can work out how many water molecules are in there. So let's do that. So mR of the iron sulfate hydrated is equal to mass over moles, 6.44 divided by 2.32 times 10 to the minus 2. That is equal to 277.5. So that's the MR of the hydrated iron sulfate. So we need to, how much of this, right, so let's just do it slightly differently. This whole thing together has got an MR of 277.5. How much of that is down to the iron sulfate? Well, that's going to be 56.5 for the iron, 32.1 for sulfur, plus 4 times 16 for the oxygen. That is equal to 151.7. So we need to work out how much is that XH2O going to be. Well, it's 2775 minus 151.7, which is equal to 125.8 grams. So the XH2O is equal to 125.8. So 1 molecule of water weighs 18. So to find out the value of X, we've got to divide that by 18. So X is equal to 125.8 over 18. That gives us 6.98. Now you know X can only be, water crystallization can only be whole number values. So the water crystallization has got to be 7. And that's our answer. Okay.